All right, 3.7 is on an ordered array. An ordered array is a listing of all the data in either increasing or decreasing magnitude. All right, so that's fancy speak for just a set of data that's arranged increasing or decreasing. If it's in increasing order, that's kind of like normally how data is given, you know, smallest to biggest. I think it's the way that our brains kind of process information. So there's a term here. First time that I've really ever seen this term was in this book, but it says rank order. That's increasing. Order. I don't have a problem with increasing order, but for those of you that have or may have to take calculus one day, increasing is kind of similar. In calculus, we have to think of things as a non-decreasing order, because if you think about it, how can a set of data be in increasing order if some of the data are the same? So either they are bigger or they are the same. That means non-decreasing. But I don't want to confuse you. Just in regular old statistics, just think about increasing order. That's rank order. And reverse rank order, I think your brains could probably figure that out before I could tell you what that would mean. That would simply be decreasing order. So pretty easy concept to understand. So if you have a set of data and the data is going least to greatest with some of the numbers maybe being repeated, then that would be rank order. And if it's greatest to smallest, then it would be reverse rank order. So here's a raw set of data and then what it would look like when it was ordered. We're going to have to do this kind of stuff whenever we're trying to figure out maybe the mode. The median, we have to do this. You don't have to do it for the mode. But when we start going over some fun statistics type stuff, we'll have to order the data sometimes. So kind of helps to keep things organized too, because if we're calculating values for like a piece of the data and we have it ranked like that or sorted, then you know maybe something that we do for 18 here, that would count for 18 here, 18 here, 18 here. So sorting the data does have its advantages. I think it's kind of just the way that our brains process things. We're just used to stuff like that. All right, 3.8 is on dot plots. A dot plot is a graph where each data value is plotted as a point. Or a dot above a horizontal axis. Dot plots can be used to help you organize data in a way that maybe you haven't seen before. So let me show you an example of a dot plot. So let's say that I took everyone's heart rate in here right now, and I am a wizard, so I can do that. And then I was to draw a horizontal axis. What's horizontal? Left to right. Kind of like the x-axis or a number line. And then on that number line, I put a lot of values, like, you know, what basic heart rates would be between. And then for each heart rate, I just put a dot above this person right here. You need to go to the hospital because your heart rate's very low. All right. So if I put a dot above each heart rate, this would be a dot plot. So maybe you've seen something like this. Maybe you haven't. Years, you know, if something is sorted by years or months, maybe I wanted to know a dot plot for everybody's the month you were born in here. It'd be real easy to make. So that's a dot plot. It's not really that tricky. It's just you take a data number and you put a dot above whatever value it would correspond to. And of course you see multiple dots over the same place on the horizontal axis. That means that was multiple data values that were the same. So like here, see, that would be 71, 2, 3, 4, 5, 6, 7. You have 5 people in here right now that have a heartbeat of 77. You are the lucky few, the lucky 5. All right, so that is a pretty, I guess, simple explanation of what a dot plot is. 3.9 talks about a time sequence plot. So plotting time series data is the name of the section. All right, and a time sequence plot graphs data using time as the horizontal axis in a bar graph or line graph. So it graphs data using time as the horizontal axis. In a bar graph or line graph. So let me find you an example really quick of what I'm talking about. I read in an article yesterday So I probably should clarify. It was 2016. It was written around January the 20-something. That last year was the hottest year on record. So, believe in global warming or not, last year was the hottest year that has ever been recorded by humans. So keep burning those fossil fuels, and pretty soon, well, it'll just be summer all year round here. Alright, so here's the bar graph. You see time is on the horizontal axis. Now, pretty common, pretty easy to read. That's just a time sequence plot. That's what that's called. It's just a bar graph with time as the x-axis, or the horizontal axis. So, not trying to make this complicated. I'm just telling you, it's just called something different than, and it's something you've probably seen. Two other terms from this section. You don't have to write this down. It's the first time I've ever seen these terms. A 3D line plot, or a ribbon plot. I may have seen that before. Is a three-dimensional version of a time series plot. So, you know, if you have a three-dimensional calculator, capable calculator, maybe you could do a ribbon plot easier. Of course, 3 dimensions drawn in 2 dimensions is kind of hard to see unless you shade or you draw things at an angle. Like this one here, you can see it's drawn at an angle here. That would be a ribbon plot or a 3D line plot. A line plot in 3 dimensions. That's all it is. Fancy name. Alright, the last section in chapter 3 is called A Look at World Population. Okay? And so all it does is go through and talk about population growth. It said that, so if we look at population growth, say over the past 50 years, and you graph the data, you can kind of keep that line going in the same, direction, and predict what the population's going to be 10 or 20 years down the road. There's a chart in your ebook that shows what I'm talking about. Let me pull it up real quick for you. Again, this is 3.10. So you can see from this chart the world population in billions. We hear words like, and I know this is kind of just a side note, but you hear millions, and you hear billions, and you hear about deficit or how much we spend on war in trillions. But do you actually understand those numbers? It's kind of hard to comprehend because we just think adding a couple zeros is what we're talking about. And I could be wrong. I couldn't be a little bit off, but I read somewhere that and I may have, yeah. So I read somewhere that 1 million seconds is like 11 days, or something like that. Maybe it's 13, 11, right around in there. And a billion seconds is 31 years or some 33 years, 32 years, right around there. And a trillion seconds is like 30 something thousand years. So you kind of, it's hard to conceptualize. The difference between a million, a billion, and a trillion is a lot. Especially when you start talking about people in billions. I mean, it's just unbelievable how many people there are in the world. But you can see, according to this chart, you could figure out about how many people there were going to be, say, in 2030. It looks like probably about 8 billion people. So, by using the growth of population over the years, I'm sure that this is some exponential function. You can use that to help project approximately how many people there are going to be on the earth. Okay. And that finishes chapter 3.